Okay, now we're looking at the seventh video of exercise 5.5 on page 127. We started with number 4, and we've gotten through till the point where we have calculated the turning point. Okay, so this is enough information to sketch the graph. Just get a ruler. It's enough information to sketch the graph. Okay. The turning point is at 2 and 3, which is approximately here. So make this a bit longer. So you got your y and your x. Okay, so this is your 0 here. Okay, if there's any mistakes I made in the video, you can refer to that number. Otherwise, these videos are free, as well as these videos are free. Or if there's an easier way to explain, or I've misexplained something, you can get me on that number. Okay. So again, let's look at the graph as a maximum. It has an x-intercept at 2 and at 4. It has a y-intercept at -16, so it's fairly low. You have an axis symmetry, as we know it happens midway between this. Alright, and at 3, it's a bit lower than that. At 3 and 2 it's turning. Okay, so the graph is going to go through like that. It's going to go through the 4 as well. Okay, so this is a symmetrical line here. So x is equal to 3. This is like the mirror image of the graph. Okay, so as you can see, what's happening on this side of the graph happens on the other side as well. Okay, now we're going to look at sketching the g of x graph. The g of x is defined by the equation 4x minus 10. So what do we do for the x-intercept? We let y equal to 0. So 0 is equal to, as we know, g of x is your y. So 4x minus 10. So negative 4x is equal to negative 10 divided by negative 4 both sides. I'm going to get 2, 5, or 5 with 2, or 2.5. It's all the same thing. Your y-intercept, for y-intercept, we let x equal to 0. So we got g of 0 equals 4 times 0 minus 10, which is negative 10. So you have 2.5 and negative 10. Okay, so if that is 3, 2.5 is midway between that. And negative 10, if negative 16 is here, negative 10 is approximately. It's all by approximation, okay? So there we go. And this, of course, is the graph of G. And the parabola was the graph of F. Okay, so there we go. So in B, the B part of the question says, calculate the points of intersection. How we work out the points of intersection? We see the two graphs equal to each other. So f of x is equal to g of x. If we look at this graph here, okay, there is 2 points of intersection. Can you see that? Let's use black here. Is there going to be that point and this point here? Okay, so we know this point at least is between 0 and a value between 0 and 2. It doesn't have to be 1. Could have been a half, it could have been 3 of it, it could be any value between those two by the looks of it. And of course this point here has to be a value between 3 and 4. Okay, so by setting the two graphs equal to each other, I got the negative 2 into x minus 3 squared plus 2 equals 4x minus 10. So we multiply this out, I get negative 2x squared. There's minus 6x be plus 12x minus 9 minus 18 plus 2 minus 4x plus 10 equals 0. Okay, so we then get negative 2x squared plus 8x minus 8 is going to give you minus 6. Now I can divide by negative 2. If you're not good with factorization, you can use a quadratic formula. At this point already, will just make life so much easier for you. So that's going to give you negative, negative. So x is equal to 1 or x is equal to 3. So those are the x values of the points of intersection. So what do I do to calculate the y values? I substitute that either into f of x or g of x. G of x is the easier one because it's a straight line, it's linear. So it's going to give you negative 6. Or g of 3 is going to be 4 times 3 minus 10. It's going to give you 2. Now if I substitute 1 into here, just check here quickly. It says 1 minus 3 is negative 2 squared is 4. Negative 8 plus 2 is negative. Okay, I think I made a mistake here. So it's negative. Yeah, it's negative 2 squared is 4. Negative 8. Negative 8 plus 2 is negative 6. Can you see that? If I substitute a 3 in, it's going to be 0. Plus 2 is 2. You see, it gives you the same answer. So as long as the points of intersection is correct, I could have substituted into either one of the two equations and I will get the same answer out. Okay. But as I said, I substituted into the straight line because it's linear, it's easier to work with. So this point here is actually 1 and negative 6, and this point is 3 and 2. Now this question was not asked, okay? So I'm just going to put it in here. Where is f of x greater than or equal to g of x? Okay? So this question is dealing with the points of intersection, that's why I put it in here now. So where is f on top of g? Or where is f more than g? So the f of x graph is this graph here. Here you can see here is less than g. If we look from on top, okay, there, you put the eyelashes there. Looking from on top, which graph is on top? This is the g graphs on top. Up until which point? The point of intersection. Here again, f is on top. Can you see that? F is on top until this point here. And then g is on top again. So that is a continuous solution from x equal to 1 to x equal to 3. So for continuous solution, I write it together. So x is greater than 1 but less than 3. Is it equal to 1? Yes. And at 3. Okay. And then the last question, the question says, this is now for C. Write down the domain and the range of f. The domain and the range of f of x and g of x. Okay. Okay. So if we look at f of x, okay, what can we say about f of x? The range of f of x is, as you can see, it's got negative infinity, positive infinity. So all the values for x. So x is an element of all real numbers. Look at the range. Does this graph exist at negative infinity? Yes. Where does it stop existing at? At the turning point. And the turning point is defined at 2 and 3. So y has to be less than 2. Does it exist at 2? Yes. So y has to be less than and equal to 2. Okay, and that's how we represent that there. The straight line, the domain, as you can see, the graph is going negative infinity, positive infinity. So x is an element of all real numbers. The range, negative infinity, positive infinity. So y is an element of all real numbers. Okay, so there's your solution to number 3. Okay.